So this is the plan and document perspective. So partly the reason that we're doing this is in the past when we taught the class, and we get lots of nice comments about the class, and changed my life, and I got a job, and it's a wonderful intern. But there were people say, oh, I've done internships before. Nobody builds software with it. In the real world, they don't do it that way, right? And even on the MOOC, there were comments like, I would never use software built with Agile. This is crazy. This other way to do it. So what we thought, we'd let you know what the official alternative unit looks like, because if you become software engineers, you may do projects like this, and you need to know what these things are. Also, it'll help you see where Agile came from and appreciate what it's doing. So this will take a little bit of while to be able to do this. So they don't use user stories, points, or velocity. What do they do instead? And it's pre-Agile. And how do you make these costs? And how do you make these schedules? So these are all the steps. If you get to be the program manager, you're going to do requirements elicitation, requirements documentation, the cost estimate. You're going to be doing the scheduling and monitoring the progress of the project. You're going to do change management, kind of like version control, for your schedule, the cost, and the requirements document. You have to ensure that the implementation actually matches the features that were kind of in the contract, right, in the documentation. And then increase the chances that you'll hit the schedule, hit the target and the budget. You do risk analysis and risk management. So these are all your tasks to do. This will take a little while to go over. So let's do the requirements elicitation. So you're looking for both what are called functional and non-functional requirements. So functional is like we've seen, right? Add a movie to rotten databases. Non-functional would be, it's a kind of a weird word, but it's like about its performance. Non-functional, it's not features, it should be non-feature, right? Non-functional means 99% response time, less than a second, or 4 nines of dependability. So how do you elicit those things? Again, that has to come from the customer, and so it's pretty much the project manager primarily doing this. Project manager tries interviewing. You want to find out how the work is really done, not the way it's supposed to be done. Maybe you send a questionnaire to all the stakeholders to have them fill them out, or you just have these informal discussions. But you're trying to figure out how should this really be done, or how is it done today. You work with the customer, create these scenarios. You start off with the initial state. You show the flow for happy and sad paths, what can be done concurrently in the final state. Third approach is what's called use cases. And there's actually there's a language called the Unified Modeling Language that helps you describe these use cases where you have little stick figures and showing all the steps from the user and the system to achieve the goal. So these are ways for the product, user requirements elicitation. What does the customer want? After you've elicited the requirements, you do documentation, and this is serious documentation. It's called the SRS in the lingo, that stands for the Software Requirements Specification. These are big, hundreds of pages. There is even an IEEE standard on how to write an SRS. So you get a document that describes a standard about how to build this document. And remember, this is inspired by software doesn't work. We got to make it like civil engineering. Civil engineering has a lot of documents. We're going to have a lot of documents, right? And then, so how do you figure out if the SRS is okay? And I'll tell you the 4 things to look at. Well, the way you do it, get the customers to read these hundreds of pages and give you feedback, or you build a prototype that has some of the features to give you feedback, or you generate the test cases to test the SRS. And so what are you looking for here? 4 things. The validity, are all the requirements necessary? Consistency, that's pretty bad if the requirements conflict. Sounds like it'll be hard to be successful. Completeness, is everything there? And all the constraints included? And finally, can it be implemented, right? So you're building this kind of book about the project before you build the project. So that's requirements documentation. How about the cost estimation? So what the manager does is decompose these, the software requirement specification into tasks. You want, bind it a little bit like, points for user stories. You want to bound the task between 1 and 8 weeks. If it's more than 8 weeks, that's too big a task. Less than 1 week is kind of hard to schedule. So your manager is looking at the task, breaking up these pieces, then given the task estimates, you convert that into dollars via salaries and overhead. That's pretty straightforward. And then when do you do this? Well, you do it before you get the contract and then after you get the contract, right? So you sure like those cost estimates to be similar, what I bid to get it and what it's going to cost the company to build it. So one idea is you add a safety margin. You and maybe you and your team work through how many weeks it's going to take to do these tasks, and you multiply by a number like 1.3 or 1.5. Another idea is you make 3 estimates. You make the best case estimate, the expected case, and worst case. And then after you look at all those estimates, then you make your best guess. All right? That's the cost model that goes ahead. And now there's 2 kind of approaches to how to do that. One's called experiential, which is basically based on the program manager's experience and maybe the company's experience. This is what our guess is, how many weeks it'll take to do all these tests. But they were trying to make software engineering like civil engineering again, so they came up with quantitative approaches. The first approach was simply, let's estimate the lines of code of each of these tasks, calculate for the company the lines of code per person month, and you divide them and you'll get how many person months it's going to take. Well, the problem with that is lines of code, Bill Gates has a code about lines of code being the wrong way to measure this stuff, so that didn't work very well. So the researchers decided we're going to measure a bunch of projects, we're going to come with a better quantitative model, and they call it the COCOMO model, constructive cost model. And it's got 2 factors and an exponent, and so they looked at a bunch of projects, and like here this is the 3 significant digits, right? I think the effort's going to be 2.94 to the times the code size and lines of code to this 1.23 penalty with a product factor of 1.07, right? You multiply that together, that'll tell you how much effort it is, put that in the cost budget. So the guys who came up with COCOMO, so that didn't work very well, so they came up with COCOMO 2, and it had 17 factors, right? So the software is getting more sophisticated over time, and they're trying to, we can make this quantitative, I know, if we just try hard enough. So not surprisingly, the survey says 92% of the time, the customer just relies on their experience to make this model. Okay, that's the cost estimation. What about scheduling? So what you're trying to figure out is what tasks you can do in parallel. And you may have heard of Pert Charts. So let me show you what a Pert chart is. It was it was developed in the aerospace industry to figure out how long it would take, or in the space, how long it would take to build a space shuttle. So each of these nodes are milestones. So these little rectangles, there's 11 milestones for the project. All right, and then these names that are on these arcs say what's being done. So this is requirements elicitation. And then what these little numbers are on the arcs are how much effort it is, say person weeks, for example. And then the arrowheads indicate dependencies. So one reason that people made Pert charts is to figure out what's called the critical path, is given all these arrowheads, what's the longest, the shortest time, no, the longest time through this effort till we get to the final milestone. And in this example, here's the critical path. So you just divide up all the efforts along those lines that tell you, and then some kind of productivity factor, and tell you how long it would take to do the project. And it could show you what things you can do in parallel. So if you're the project manager, you did the SRS, you break it into tasks, you get it into costs, and then you use those to create the schedule using something like Pert charts. Now that you've made a Pert chart, what do you do while the project is going? Well, now you want to compare what you predicted to how long things are taking, and so you track both the actual expenditures and the time for those tasks, maybe against your Pert chart. And what they found is that by sharing these intermediate milestones, there were 11 milestones on the slide, everybody is aware of whether you're on budget or on schedule or not, both the people building it and the customers. Okay, so this is, can you build it in time, and on budget? But you're not done as project manager. Does it actually do what you want, what the customer asked for? And this is called requirements traceability. So there's tools that are developed to try and tie in all these pieces together. The software requirement spec, what piece of the software requirement spec is associated with the piece of code that implements it, which is associated with the tests that validate that. So by having these tools to keep those together, you can ask yourself, well, did we really implement everything the customer asked? Well, let me go in and test. Is it passing that test? Well, good, because then it's handled that piece of the requirement. So are all the pieces of the 100-page document covered with tests and the corresponding code in the SRS? And then if the code changes, you want to go back and test that. Now, to try and increase your chances of hitting the target, there is, borrowed from the business school, is risk analysis and management. So basically, you're trying to make this more accurate. So you're trying to guess what the risks are going to be before you do it. And so what do you do if you identify a risk? Well, you can do extra work to reduce the risk, do extra work to prepare yourself, or change your plan so that risk goes away. So a technical challenge, hey, the relational database won't scale to be big enough. Well, maybe we could find a bigger machine with a bigger relational database so we can make that risk go away. Boy, our organization isn't familiar with J2EE, which we have to use to build that. What can we do to mitigate that risk? We could send them to, we could take tutorials, online tutorials to get them better at J2EE so that risk is mitigated. Oh boy, the business risk is it's going to be too late for the market. Well, maybe we should cut back the features so we can get it in the market in time so that it'll be viable, right? Or you know, if it's really bad, then we shouldn't do this at all. So, boy, you can imagine, you're guessing the risks. So what's the advice you should do? Well, try and you guess what the risks are, make your best guess of the chances of this risk happening, and then on your own 10-point scale, give it an impact factor. Boy, if this thing happens, how bad it'll be for the project. And then you multiply the chance times the impact factor, and you come with a number, and you sort your risk by that, and then you tack the top 20%, and you're hoping that that's most of the risk. And so the risk analysis is trying to hit you on schedule. So these are all the things you need to do as a manager, and we put this side by side in the table, which you may be able to read. So here's the 7 steps on the left. So the requirements, documentation, elicitation, change management, schedule budget, ensuring requirements features, scheduling and monitoring, that's all that corresponds to user stories, points, and velocity, right? So user stories, points, velocity, which I just talked about in the last couple of segments, is, you know, relatively intuitive. Boy, this is what that replaces, right, for Agile. And then the cost estimation is this kind of loosey-goosey thing we talked about. Instead of trying to hit it and promising it, delivering features, and doing extensive risk management to make it more likely, well, you're saying you're doing it on a best effort approach. Okay, so that's what it means. That's the alternative universe here that many of you, a lot of people do use for lots of projects, and you may do yourself, that helps you to see what's different about Agile. Okay, so let's see with going ahead, which expression regarding plan and document requirements and cost estimation is false. The closest to plan and document scheduling and monitoring tasks are Agile points of velocity. The closest to plan and document software requirements spec document is Agile user stories. Agile has no equivalent to ensuring requirements such as traceability. And actually, they're all true. None of them are false. Okay, so why don't you pause over that one. All right, let's get the first vote up there. Ready, set, vote. All right, lots of colors, so talk this one over. All right, let's try and vote again. Ready, set, vote as pairs, go. Wow, that converged. All right, working magic. Let's go over them. So the closest to plan and document scheduling and monitoring are Agile points of velocity. Yep. Agile is using kind of retrospective. What's the experience of your team in assigning points and how fast you use them to predict the future? That, as opposed to in advance making the schedule. That's a big difference. The closest to the software requirement spec for plan and document is Agile user stories. Yes, those little tiny 3x5 cards are your written documentation of the specs that you work with the customer. And that's as opposed to a 100-page book or hundreds of pages book and an IEEE standard. Agile has no equivalent to ensuring requirements such as traceability. Yes, that's what the BDD is. BDD gets the requirements into user stories, and we'll see shortly that we can take those 3x5 cards and turn them into acceptance tests. So we're going directly from the customer, get them right in cards, what the features we want, implement them iteratively, and that's the acceptance test where make sure those features are there, where it's not part of plan and document, so they have these traceability tools to try and make sure you do that. And so actually 4 and 3 were false, but that would have been kind of clever. Okay, questions about this? Questions about that? Good. All right, so that's what this alternative universe looks like. So when you guys make these comments, oh, I know how software is really built. Okay, yeah, there's another way to build software. This isn't the only way. It's got positives, and you know, if I was doing space shuttle stuff, I'd probably use the plan and document with all that stuff, but not for a lot of things. Okay, so let's go ahead and we'll have time to do one more segment about comments. So this is again another thing about writing beautiful code. And this is what's interesting. I have two of my good friends are Armando Fox and John Osterhout. John Osterhout used to be a faculty member here. One of the best programmers I've ever met. And he and Armando just do not agree about comments in general, right? Armando believes in self-documenting code, and Oosterhout thinks that's evil. Self-documenting code is evil. So let me go over Oosterhout's advice, and we'll talk a little bit about where they agree. Okay, so examples of bad comments, which they both agree on this. So here's a good, useful comment. Add one to I. Well, thanks. I'm glad you didn't. Glad you did not comment that. Boy, without that comment, I don't know what I would have figured out. Okay. Here's another one. Lock against spin lock mutex. Oh yeah, that's yeah. So you're writing down what it does, right? This function swaps panel, void, swap panels, panel 1, panel 2. Right? Oh, great. Thank you for doing that. So what the idea is for good comments, and Armando would agree these comments aren't good, but what Oosterhout says what's missing is the reason why you did it. What's the motivation? Don't write comments about what it is put in the why. You can't figure that out from the code, the why that you did that. So that should be here. And you want to put comments at a higher level so that if you change, when you change the code, which you ultimately will have to do, it doesn't break the comments, right? So, so here's an example. So if we're going to be scanning an array to see if the symbol exists, do it that way rather than basically kind of implement the code you know, in comments, right? This is a much better comment to be able to doing it. Now, what's tough about comments is there's not lots of good examples. Like open source has terrible comments. If that's your example, it's rare that you see good comments in this. When on Oosterhout's code, there's as many comments as there are lines of code there. That really helps it. So, you know, so I think Armando agrees with the why part of this, that writing down why is a good thing, but he liked to believe with the elegance of Ruby that you can, and good variable names and stuff like that, the code can be understandable without the comments. But he would agree that, you know, you can't capture the why in there. And then, you know, and one of the big things about the legacy code is when you're trying to figure out what's going on is typically that there's no comments there that you want to try and work on that. So I mean, basically, when I talk to my friend Oosterhout, and I think he agrees with this point, what I really love about this course is virtually every time we tell you a good idea, there's a tool that implements that, a good idea. So what about ABC complexity? Oh, we got flog for that. How about cyclomatic complexity? Oh, that's Sakuro, or smells. Oh, that's Reek, right? Good comments, we don't have a tool, right? The problem with that is we'd love to have some, if there was a natural language understanding tool that say, hey, this is a really good comment, that'd be useful. But what I like about the course is the advice we give you, you can follow, and we can see if you follow the advisor's tool to do that. With comments, it's, you know, somebody has to read through the code to see if you're writing good comments, and that's not as scalable, so we can't make the class as big as students would like. So let me wrap this up. So we started off with giving you advice of how to write beautiful code in SOFA. Short, do one thing, few arguments, and consistent abstraction, so you don't have smelly code here. And these metrics will point to areas of concern. They're not a foolproof guarantee, but they're good indicators. Big idea of behavior-driven design is these user stories and lo-fi user interfaces to be able to work with the customer right now to be able to figure out what they want, and you need to do that. How to make good ones? They need to be specific, measurable, achievable, relevant, time box. Tracker is this useful thing to be able to calculate progress. And boy, this other universe is, you know, the project manager, they get the good pay, but boy, there's a lot on the line to try and be successful. Okay, with that, we'll see you next time.